Hello everybody. Today's lecture is going to be on what is statistics. I don't know if you thought about that too much, but why do we need statistics in the first place? Why is it important to us? And I'd like you to start this by having you think about when you made a decision, where you made your decision on absolute complete knowledge. I don't know, would we even call that a decision? Because almost everything in our life, when we make decisions, we are making it on incomplete data. Even if we think it's, 99% sure. We're always trying to make data on less than complete information. And in business, the better quality decisions we make, the better we manage, or the better our organizations perform, and it becomes very important to us. And statistics is a tool to help us make better decisions. Statistics is the art of distilling meaning from data. We're going to define data in a minute or two. It's a way to help us understand the environment and the world around us. I want to point out that statistics is plural. We don't say I study statistic, which means that statistics are quantities that we calculate from data. And it's the science of collecting, organizing, presenting, analyzing, and interpreting data to help us make more effective decisions. And one of the process maps that I have liked for a long time ago, is do, plan, do, and report. Plan, do, and report. Plan meaning think about what you're going to try to figure out, do it, and then make sure you report it, which ties back into this concept of organizing, presenting, interpreting data to make more effective decisions. Okay, so there are two major types of statistics, and we're going to break the course largely into two major segments. One is understanding and addressing descriptive statistics, and then we're going to move to talking about inferential statistics. So descriptive statistics are methods of organizing and summarizing and presenting data in an informative way. It is trying to take our data and be able to really to understand it and present it. Inferential statistics are methods that we use to actually make decisions. And so the first part of the course, when we're talking about describing data and understanding it in inferential statistics, is we're going to try to find and learn about statistics that will help us make decisions. In order to do that, we have to start with understanding what data is. So data are first of all, the term data is plural. If I were to talk about your weight, that would be singular, and we would call that datum, a datum. And if we talk about the weights of everyone in our course, that would be plural, and we would call that data. So whenever we're talking about data, we're talking about multiple datum points, okay? Data are values along with their context. And I cannot underscore enough about how important understanding context is. So if I were to tell you, here's some numbers, 250, 500, 350,000, those are all thousands, $1 million. What does that tell you? Well, we know that that's data, correct? But we don't know anything about what it is. So then if I tell you, oh, well, that's the average sales price, well, that tells us a little bit more. Average sales price of homes, that tells us a little bit more. The average sales price of homes sold in San Diego County last month. That's important, right? If I told you all of that but didn't tell you when it was collected, we wouldn't know whether that was last week, last month, last year, right? And if I'm comparing two sets of data, one happens to be last week, one happens to be last 10 years ago, then if that's what we're trying to analyze, that's one thing, but if we weren't trying to analyze it, it would be important. Real life situation, I'm looking at delinquency performance of a particular loan portfolio, and I happen to see that, say, 30, 60, and 90-day delinquents, that would be 1, 2, and 3 month payment delinquents, here's what the averages are. And I'm comparing that to national numbers. Let's say I have the national numbers. If my statistics are as of this month end, but the national numbers are as of last quarter end, I need to understand that, right? And so the context is very, very important. And you'll think in terms of the 5 W's, right? The 5 W's. So I want you to just remember that. Who, what, when, where, why, okay? All right, so next. The types of variables that we're talking about can be classified into 2 major segments. Qualitative, also known as categorical, or quantitative, also known as numerical. So qualitative, and I mention that because some books will use one term over the other or in place of the other. So categorical is qualitative, quantitative is numerical. And qualitative can be, it's descriptive, like what types of advertising do you use? What kind of color car do you like? They might have questions that are yes, no, or come from answers like that have questions that have yes, no. And it may be a number. It may be a number like zip code. Zip code is a qualitative variable. Quantitative numbers have to have units, right? And each value has been measured, and they have some correspondence to a scale of measurement. So when we're talking about numbers that are tied to a scale, then we would be talking about quantitative numbers. When we use the term zip code, is that tied to a scale? No, it's really not. It's just an assignment. So if I were to use the numbers, 1 referring to freshmen, 2 to sophomores, 3 to juniors, 4 to seniors, right? Is the 1, 2, 3, and 4, are those qualitative or quantitative? It's a number, but it's not really tied to any scale. So it is a qualitative variable. Okay, so quantitative or numerical variables can be further described as discrete or continuous. So if we were to talk about a discrete variable, that's something that can be basically be counted. How many cars do you have? I have 3 cars. That's discrete. I have 1 car, right? Continuous would be how many miles do you drive each day? And that might be I drive 12.35 miles, right? Or what is the amount of rainfall that we have in San Diego? That would be a continuous variable, right? Discrete and continuous. So let's move on here. The levels of data determine how we what measurement we're using, and that tells us what how we should summarize the data and how we should present it, and it's furthermore going to be important to us as to what statistical analysis we can perform on that data. And we classify those into 4 different primary categories. 1 is nominal. And nominal is data that is represented as labels or names, and it has no order. It can only be classified and counted. All right, so that's nominal data. Ordinal data is basically nominal data, but now it has some value if we can rank order it, like the best city to live in, or we could look at what a freshman, sophomore, junior, senior, right? That would be ordinal data. We can rank order it. Interval data is data that can be measured on a scale with a known units of measurement, like our temperature, right? That has units of measurement. Ratio, the highest level, is very similar to interval, except for that it has a meaningful interpretation of 0 on the scale. And so that becomes more important. For instance, what is how much income you make, right? That would be a ratio level. 0 has a meaningful number to it. All right. So my last point or two that I want to make, and this will probably sound a little bit odd to you coming from somebody who teaches statistics, but it's a very important concept, and that is we should always be skeptical. The reason why we use statistics is to analyze data to try to get at the truth of understanding that data, correct? And it can be misused, and you will frequently see statistics being misused in trying to use statistics to persuade or to confuse or to point us in a direction that was intentional. It really wasn't used for us discovering something that we really want to discover. And ethics is a very, very important pillar of how we study and utilize statistics. So I want you to keep that in mind. And you don't have to look very far to see statistics being misused all the time. In a lot of the advertisements that we see, you see misused statistics all the time in the political arena when it comes to campaigning. When they're talking about when they're talking about candidates or particular initiatives that are on the ballot. And we'll talk a lot about that when we get into doing polling and when we talk about using and doing sampling as to the impacts of not doing that thoughtfully and correctly. I hope this has been helpful, and we'll talk to you later.